So welcome one and all. So today we are going to, in this video we are going to discuss about linear differential equations. The immediate applications of linear differential equations we will find in RC circuit or circuit analysis theory. So now we will see the first order linear differential equations, what is the general form and how to solve this type of equations, and what is the method that we have to follow to solve these equations, that we will see today. So the general form of first order linear differential equations is given something like this: dy by dx plus p of x into y is equal to q of x, where this p and q are functions of x. So this equation is nothing but known as linear in y, in the variable y. Linear in the variable y. So here the variable y is known as the dependent variable and x is known as the independent variable, that all of you know that. So whenever you find any equation in this format, this is nothing but known as the first order linear differential equation in y. Now how to solve this first order linear differential equation? So for this differential equation, the standard procedure is given something like this. We have to multiply this differential equation with an integrating factor given as integrating factor is equal to e power integral of p of x dx. Now let me tell you what is this integrating factor. Integrating factor is nothing but a function which simplifies the given equation or which converts the given equation as an exact differential by multiplying with this function. So let me once again repeat. Integrating factor is nothing but a function. By multiplying the given equation with this equation, the equation get transformed as the exact differential. So that is the definition of an integrating factor. Now especially for this type of equations, linear differential equations which are linear in y, the integrating factor is defined as e power integral of p of x dx. Now we will see what will happen if we multiply this differential equation with this integrating factor on both sides. That we will check it now. Now if you multiply this differential equation with this integrating factor on both sides, then we get e power p of x dx into left side we have dy by dx plus p of x into y is equal to, right side also we will get e power integral p of x dx into, already we have q of x. That's what we will get by multiplying with this the integrating factor on both sides. Now if you observe, this entire left hand side is nothing but the exact differential of y into e power integral p of x dx. So just by applying UV rule for this, if you find the derivative for this, then you will get exactly the same. So which is equal to e power integral p of x dx into q of x. So by multiplying the differential equation with the integrating factor e power p of x dx on both sides, this entire left hand side of the equation get reduced as a exact differential of y into e power integral p of x dx. Now you just integrate this on both sides. If you integrate this on both sides, then we get integral of d by dx of y into e power integral p of x dx is equal to integral of e power integral p of x dx into qx dx, and of course we will get an integral constant c, or otherwise we can call it as the arbitrary constant c. And here the integration and derivative as both are inverse to each other, then we will get the left side as y into e power integral p of x dx is equal to integral of e power integral p of x dx into q of x dx plus c. And of course, in the simplest form we can write it as y into integrating factor is equal to integral of integrating factor into q of x dx plus c, where c is nothing but known as the arbitrary constant. So for the differential equations, especially the linear differential equations which are in the form dy by dx plus p of x into y is equal to q of x, the general solution is given as y into integrating factor is equal to integral of integrating factor q of x dx plus c, where the integrating factor is given as e power integral p of x. So this is the procedure how we can solve a first order linear differential equation which is linear in y. Okay, so this is the procedure that how we can follow. Okay, now we will see how to solve problematically one problem. So now I have taken a problem like this: 2 into y minus 4x square dx plus x into dy is equal to 0. Now first of all we will check whether we can convert this problem into the standard form of linear or not. Okay, so for that let us see the solution for this. Now we can write it as 2y by x minus 8x plus dx dy by dx is equal to 0. Just by dividing on both sides with x we can write, so 2y by x minus 2 4 2s are 8, x square by x means 8 you get, plus dy by dx you will get is equal to 0. Now we will try to convert this one into the standard form, which we can write it as dy by dx plus 2y by x is equal to 8x we get. Now you take this one as some equation 2. The given equation as equation 1 we can write. So now the given equation reduces, or given equation can be written in the standard form of the linear differential equation, which is in the form of dy by dx plus p of x into y is equal to q of x. So whenever you compare this equation 2 with the standard differential equation, that what we have discussed in the previous slide, here we will get it as p of x is nothing but 2 by x and q of x we got it as 8 by x. Now by using the procedure 8x, now by using the procedure directly we can solve this by using the integrating factor. By the definition we got the integrating factor as e power integral p of x dx. This is nothing but the integrating factor as per the definition, and which is nothing but given as e power integral p of x means, what is p of x? Here we have 2 by x dx we will get. So means this is nothing but e power 2 log x. Log x means here base e here. So which is nothing but e power log x square, we can write it by using the logarithmic formula, and e power log x square base e means we can write it as x square. So the integrating factor here we got it as x square. Now as per the definition, the general solution is nothing but given as, by the definition, the general solution is the general solution is given as, we know that y into integrating factor is equal to integral of q of x into integrating factor dx plus c, where c is an arbitrary constant. That implies y into, already here we got the integrating factor. The integrating factor we got it as some x square. So y into x square is equal to integral of q of x. What is q of x? Q of x, here we have 8x into integrating factor again. Integrating factor is, here we have x square. So 8x into x square into dx plus c. So means now just by applying, so the basic integration formula, here we can write y into x square is equal to, here we have 8x cube. So 8 is a constant and integral of x cube is x power 4 by 4. So plus c, where of course, so with some minimum calculations and all, here we can write it as y into, y into x square is equal to 2 into x power 4 plus c. Of course, where c is an arbitrary constant. So this is nothing but the general solution of the given differential equation. And finally, of course, we can write, of course above here already we wrote, but once again we can write, in the sense we can conclude it as, which is the general solution of the given differential equation 1, because we have taken the given differential equation as equation 1. So therefore at the end of the problem, just we can conclude like that, which is the general solution of the given differential equation. So let me conclude once again. The general form of the first order linear differential equation is given as dy by dx plus p of x into y is equal to q of x, and its integrating factor is given as e power integral p of x dx, and its general solution is given as y into integrating factor is equal to integral of q of x into integrating factor dx plus c. So this is all briefly about a first order linear differential equation, the general form and the integrating factor and the general solution by using these three methods. Whenever any problem is given, so first of all you will try to convert that one into the standard form, and then you identify or evaluate what is the integrating factor, and then by using the definition for the general solution we can find out the solution very easily. So this is how we can identify and we can solve the first order linear differential equation. In the next class, next video, we will see some more problems on this. Thank you.